Hi, my name is Christina, and the molecules that I'm going to be doing are CS2, and on the back there is PF3. So for CS2, here is a Lewis dot structure, and for CS2, the VS-EPR formula is AX2, and the reason why it's AX2 is A stands for the essential atom, and X2 is for the atoms that surround C, so there's 2s, so X is going to be 2. The electron group arrangement and the molecular shape are both linear, and here is just a little picture I drew for the linear molecule. The bond angle for CS2 is exactly 180 degrees, and that's because it's nonpolar, so there's no lone pairs weighing it down. And over here, it shows partially positive and partially negative. So here, C is partially negative and the S's are partially positive. The molecule is nonpolar because the dipole moments cancel each other out. And the hybrid orbital is sp. And it's sp because if you look back at AX2, so for the hybrid orbitals, what you have to do is you add X plus E, and there's no E, so there's only 2. Which means there's going to be 2 total bonds. So the first bond goes to S, and that's going to only carry 1. But then the next letter is P, and that's going to carry the next bond. Also, there are 2 sigma bonds and 2 pi bonds for CS2, which are here. Intermolecular force is covalent, and the intramolecular force is covalent, and the intermolecular force is London dispersion. The formal charges of carbon is 0, and the formal charge of S is 0, and if you think about it, it makes sense because when you add it up, it's just 0, and there's no charge for the overall CS2. And there's no resonance, and CS2 has a complete octet, and it has the order of 2 because there are 2 bonds. So my next molecule is PF3, and here's the Lewis dot structure for PF3. And then the VS-EPR formula is AX3E, and it's AX3E because there are 3 atoms surrounding the central atom, so the 3 F's are going to where this come from, and then E is for lone pairs on the central atom, and here is the lone pair. And the electron group arrangement is tetrahedral, which is the general shape. And the molecular shape is trigonal pyramidal, which is the more specific shape. And here's just a picture of what the specific shape looks like. And the bond angle is going to be 109.5 degrees, and that's because the lone pairs are weighing down on the molecule, which are going to cause it to go down a little bit. And the molecule is polar because the dipole moments don't cancel each other out. And the hybrid orbital is sp3, and this comes from the VSPR formula, which is AX3E, and you add X and E, so in total there's 4. So 4 total bonds, so the first one goes to S, which can only carry 1, and then the next 3 go to P, which can only carry 3. And there are 3 sigma bonds and no pi bonds or resonance bonds. The intermolecular force is covalent, and the intermolecular force is dipole-dipole. Also, PF3 has a complete octet, and the bond order is 1. Also, here are partial positive and negative. So here on the F's, there is partial negative, and for P, there is a partial positive. And here's my models. This one is for CS2. This one is for PF3.